Hello everyone, in these notes we'll discuss the Shiny app for interactive visualization. So there's a lot of vocabulary, but I hope you'll find it's actually relatively logical. So the first important word, the UI and server elements. Every Shiny app has UI and server elements. In fact, in order to call the Shiny app command, you need to pass in both as arguments. What are these? The UI stands for the user interface. Here there's just a title and an input where the user can type something in. The server here is empty. This app is not actually doing anything. But you could imagine that in a more complicated app, maybe the user queries for some sort of information, a lot of computation needs to go on in the background, and then that information, the result, needs to be sent back to the front end. The thing that's going on in the background, that's what you would put in the server. Okay, so here, app, it only has input. You can type in whatever you want as input, but the app is not actually going to do anything. Okay, so that's the highest level distinction. Within UI elements, there's a further categorization. We've already seen two categories. There are these kind of descriptor, just titles, paragraphs, any kind of text that's not ever going to change. They're inputs. These are things that the user can specify some information. It could be text, it could be numbers, it could be checkboxes. We'll see examples of all of these later. Something that's not in this UI, but which we will see soon, are text outputs, or different kinds of output. Right? It could be a plot, it could be a table, it could be text. These are things that are computed by the server, and you need to show it to the user after the computation is done. Okay. So that's the next categorization. An important point, every element needs to be given a unique ID. That is how the app knows to refer to different elements. Right? So here I've specified that this text input, the ID is name. Now if I ever need to do any kind of server computation and it needs to depend on that input, the way it's going to refer to it is through that label. Okay, so this has been, so far, a pretty underwhelming app. Let's look at something that actually does computation. So let's look at the app before we look at the code. All it's going to do is, if I type in my name, it's going to update, and it's going to show my name in the text, right? And I can keep on doing this. Do this. Yeah, okay, you get the idea. Every time you type in some text, it's outputting this text here. So this is how this is done. Okay, it's like what I said. You have text input, but now you have text output. Right? The code almost writes itself. How does the text output work? So this is something that's regenerated every time the input is changed. Right? So it needs to be, there's some computation involved, actually. You can't specify it in advance. So the computation is involved. We're just pasting this welcome to Shiny with whatever the input was. Whenever that pasting is going on inside of this render text element, the render text gets put into printed name, and it goes back into this output. So, okay, that was many steps. There's kind of a loop going on. You start with an input called name. The loop goes down to this input $name in the server. This input $name is all contained within a render text element. The output of that render text element goes to printed name, and then the loop gets complete by printed name going back into a text output. Okay, so really important point is that I can't just, you could imagine wanting to write, output $printed name is just paste 0, welcome to Shiny, input $name. You could imagine just ignoring the render text entirely. That would not work. Right? Anytime you refer to an input, you need to include it in either a render environment or a reactive expression, which we'll see in a minute. But you cannot refer to these inputs outside of these special kinds of environments. Okay. The second important idea is these labels. These are everywhere, right? So you needed to have a good name for this label for the text input so that you can refer to it in the server. You also need to have a name linking the output in the server to the output here. Okay, the final point want to make is that there's always going to be a certain kind of pairing between the outputs that appear on the server and the outputs that appear in the UI. So if I had a render text, you need a text output here. If I had render plot or render table, I would need a plot output or a table output here. They're always matched. Okay, so that's what I wrote here. Okay, conceptual point. Usually when you write code, you expect the code to execute one line at a time. It's linear, it's top to bottom. What we just saw, though, is code that got re-executed every time the user changed something. The code is not running top to bottom. This can make debugging a little bit tricky, because you can't just go line by line. But we'll see some examples in the next lecture about how to reason about code which isn't executed linearly. The name for this kind of execution is called reactive execution. The code reacts to whatever the user is doing. Okay, let's look at some more examples. Conceptually, there's going to be nothing new, but it'll give you a sense of the variety that you can make. So let's look at the actual app before we look at the code. What it is a histogram of random normal numbers. I can change the mean. Right. Let's play around. It's just changing a histogram where I generate new random numbers around that mean. How is this being done? Instead of a text input, I'm giving it a numeric input. That's why I'm able to enter numbers here. Instead of a text output, I'm giving it a plot output. So the output is itself a plot. That's being wrapped in render plot. All render plot is doing is it's generating a ggplot histogram where it's creating these new random numbers, 100 of them, around the mean specified by the user. Again, there's this loop. The loop is going from the numeric input mean down to here, input mean within the render plot. That's stored in an object called histogram, and histogram appears in the output. So that was just one input. We could have several inputs, right? So now, getting fancier, I have the mean, but I also have sample size, I have standard deviation. I'm doing them using these sliders. And so you might have seen these in different kind of web pages, right? They already come packaged for you within the Shiny package. So the way it was defined, this is what the user sees as a label. This is the initial value. This is the range of the slider. That was several inputs. We could do also several outputs. So let's look at this example. It has a histogram output. It also has a table of numbers. Right. What was the implementation like? Instead of having one output, I have two lines for the output, a plot output and a data table output. In this data table output, I've populated it using a render data table. Now, this all looks fine, but there's a bug. And maybe take a second to see if you can spot it. The issue is that we're generating new random numbers in both of these render calls. So even though when you look at the plot, I think most people would assume if you saw a table of numbers below a histogram that those numbers corresponded to what's in the histogram. In this app, though, they are totally different numbers. Right? They're two different draws from a random normal. This call is different from this call. So how would we fix this? We need some way of generating random numbers that's going to be shared by both of the outputs. In general, you can imagine needing to share computation across several outputs. To share computation in Shiny, you can use something called a reactive expression. So this is an example of a reactive expression. It's creating a single data frame with this rnorm call. And now anytime any of these three inputs are changed, it executes the reactive expression. And that reactive expression appears in both the plot and the data table. But the key point is that it's the same set of random numbers because they're using the same output from the reactive expression. Okay. It also cleaned up the code a lot, right? I don't have to generate these data frames each time. Okay, and on that note, a nice way to clean up Shiny code, or just to make it much more readable, is to separate the logic needed for the app from the logic needed to execute within each part of the app. What I mean is, let's look at this. This is the example of the cleaned up function. Right. Really, the UI and the server is just telling the relationships between different kinds of computation. But I'm not writing out the entire ggplot code anymore. Right? So render plot, instead of before I had the whole ggplot code, now I'm just calling this external function that draws the histogram. Right? And the server itself is very short. Right? So this kind of code externalization can really make your Shiny app code much more readable.